today's lesson, we're going to look at linear inequalities in one variable. And before we actually start solving and graphing, I wanted to go over graph each given set. So here, the first one is asking set x such that x is smaller than 3. So if we wanted to show x being smaller than 3 in a number line, we use number line because we only have one variable, right? We are going to, if this is 0, we're going to mark 3. And smaller is going to be on the left side of that number. So every number that's left of 3 is smaller than 3. And because x being smaller, you're going to use either parenthesis, or you can also use the open circle, like that, right? So either one will be okay to show less than. And one other thing is, if you wanted to show this in interval notations, you started with parenthesis, right? So you will have parenthesis for the interval notation on the right side. And you're going to have parenthesis on the left side also because it goes all the way to infinity. This is negative infinity, right? Whenever you're including infinity, you're going to use the parenthesis also. So interval notation, you're going to have parenthesis, and you're going to copy down the number. So started with 3, right? From 3 to negative infinities. So we call this is going to be graph of given set, and this is going to be interval notations. What about if we're looking at the next one? We have x such that x is greater than or equals to negative 1. So on the number line, we're going to use negative 1. And because it's a greater, it will be on the right side of negative 1. So color all the right side of all the way, because you don't have any limits, you're going to color all the way to positive infinities. And this time you have greater than equals to. So you're going to use the bracket instead of parenthesis. So whenever you have an equal sign with it, then you're going to use the bracket instead of parentheses. Or if you wanted to use the circle, it will be closed circle. Closed circle, going all the way to right directions. And you can use either one. And if you wanted to show this solution into the interval notations, use the bracket. On the other side will be parenthesis because positive infinity start from where? Negative 1. So this is your graph, and this is going to be interval notation of the solutions. What about the next one? We have x such that x is smaller than or equals to 3, but greater than negative 1. And we always read from the unknown variable. So since this one have x in the middle, you start reading from the middle. So x is less than or equals to 3, greater than negative 1. So we're going to draw the number line again. And always the smaller number on the left side and larger number on the right side. And x is greater than negative 1, less than 3. So we'll be between those two numbers. And 1 is going to be parenthesis because not equal sign. 3 is going to be with bracket because have equal sign, right? Or you can use open parenthesis with closed circle. Open circle with closed circle, right? Like that. Either one. And interval notations, negative 1 was parenthesis. So left side was parenthesis, right side was bracket, and put negative 1 and 3 in the middle. and that's going to be your interval notations. So now let's see if we can solve and graph. So when it's dealing with inequalities, right, we know how to solve equations. So solving equations and inequality is going to be identical. Only thing it's going to be different is whenever you're dividing or multiplying with negative number, then you're going to flip this inequality signs. That's on top of how to solve equations, right? So let's just looking at the first example. It's a 4x minus 7 is greater than equals to 5. So first thing, in order to solve this, first thing I will do is adding 7 on both sides, because we're trying to isolate x, right? And then you will get 12. And now you're going to divide with 4, so I can isolate x, which I will get 12 divided by 4 will be 3. So this solution right here is going to be x is greater than equals to 3. And when you wanted to graph this, it's going to be, let's say 3 here, and x is greater than equals to, so bracket and highlight greater, right? And interval notations will be 3 to positive infinity. Or if you wanted to write your solution with set notation, it's going to be x such that x is greater than equals to 3. Either solutions. Depends on how they want you to answer. You have 3 different ways of answering. One with the graph. This is interval notation. This is set solutions. Let's look at the next one. This one, you're going to put number with the variable together first, right? So I have 6x here, 8x there. I wanted to put it together. Number without the variable, I wanted to put it all on the other side. So first thing I will do is adding 12. So no more number by itself on the left side, and I wanted to put number with the variable to the left side, so I will subtract 8x then. Subtract 8x. So no more variable x on the right side this time. So I will have negative 2x on the left side and positive 14 on the right side. And if I wanted to isolate x from this point, you need to divide both sides by negative 2. Remember, whenever you're dividing or multiplying with negative number, and right now that's what I'm doing, I use negative to divide, right? Then you're going to flip your inequality. So your inequality is going to be less than, right? Because you divide with negative number. And here you're going to have x by itself. That's going to be negative 7. So your solution is going to be x is smaller than negative 7. And you graph this. If this is negative 7, smaller than, so we'll be on the left side. And use the parenthesis, right? Interval notations will be negative infinity from negative 7. And in interval notation also, you wanted to write the smaller number on the left side, larger number on the right side. Same thing as the graph, number line. Or if you wanted to show with the set notations, you could say x such that x is smaller than negative 7. Let's look at one other one. This is longer one. So first thing I wanted to do is open the parenthesis by distributing one term into 2 terms, right? So it will be 2 times x, 2 times negative 3 is negative 6, plus 5x is less than equals to 8x minus 8. And I do have like terms, so 2x plus 5x is 7x. And everything else will be same. This time what I wanted to do, I wanted to move number with the variable on the right side. Why do I want to do that? I mean, it doesn't matter where you're going to move, but I wanted to show you what happens if you have the variable on the right side. Because usually what you see on your solutions, x is usually on the left side. We're more familiar with having x on the left side, but let's see what happens if we have x on the right side. So, and at the same time, if we wanted to put x on the right side, this problem, because 8 is larger than 7, you're going to have positive x, right? So let's see. What you're going to do is you're going to subtract 7x and add 8. So no more variable on the left side, no more number on the right side. And you get, it will be 2 is smaller than equals 2. That will be 1x. So since we didn't have any negative, you don't have to divide. So this is going to be, you're going to read it from, always from the variable. So you're going to read it from right side. Your x is on the right side. So you're going to say x is greater than equals to 2 this time, right? So if you wanted to rewrite this, this is same as x is greater than equals to 2, right? Because this right here, this is open, right? X is on the side of open, which is the greater means. So when you graph that, if this is 2, x is greater and equals 2. Interval notations, 2, 2, positive, infinity, or x such that x is greater than equals to 2. The third example we have in this section, we're going to look at when you have a three-sides inequality. We call this compound inequality. So you have three sides. You have a middle side with the variable, and you have 1 and 2 inequality. So it makes it three sides. This compound inequality, the way you're going to solve it is not much different than the other one we're looking at it. So usually what we do with the other ones is trying to isolate x, right? And whatever that I do to trying to isolate x, here on the left side, you do exactly same thing on the other side, right? First, I need to add it, and then I need to divide it, right? And you do both sides, whatever I do to isolate x. So this three terms, same thing. Whatever I do in the middle term to isolate x by itself, you're doing it all three sides, okay? So first thing you need to do is subtracting 1. So let's subtract 1 all three sides. That will make it -4. And 2x in the middle. And that will be +2. Now we're going to divide by 2 to isolate x in the middle. That will give me -2. And that will be x. And that will be 1. So it's saying x is smaller than equals to 1, greater than -2. And your graph should be smaller number on the left side, larger number on the right side. X is between, right? And 2 is not included, and -2 is not included. 1 is included. Right. Let's look at another one. What about B? So we do exactly same thing. Whatever I do in the middle, I do all three sides. So first I need to add 4. if I have to divide by negative or multiply by negative number here in compound inequality, then I have to flip my inequality also. But so far I'm not doing that, right? I add 4. Then I will have negative 2. And that will be 1/2 x. And that will be positive 1. In order to isolate x in the middle, I need to multiply by 2 over 1, right? So I multiply 2 over 1, multiply by 2 over 1. That will cancel denominator. So in the middle will be just x. And that will be 2. And this is going to be negative 4. So in other words, it's saying x is smaller than 2, larger than equals to negative 4. Let's graph. Negative 4, positive 2, x is in the middle. And this one is include, so bracket, right, because you have equal sign. This one is not include, so it will be parenthesis. Or if you want to, color circle or open circle, like that.